Good morning. I hope that you're doing well. I am doing fairly well given the circumstances, and I'm sure the foreboding thumbnail for this live stream has made some of you a little bit worried, but thankfully nothing's too bad. It's all recoverable. It's just a bit annoying is all. But there's one thing I want to get to before talking about what damage has occurred. And that is something that I mentioned in the last stream, which is that I'm using these XT60 connectors for plugging various things into each other. And someone suggested something that was really, really simple and has worked very, very well. So my issue was that these connectors were too tight, and when having them together, it was very, very, very hard to pull them apart. And I was always under the impression that a lot of the friction that was connecting these two things together came from like the plastic sheathing on the outside, but it actually turns out that most of it is from the pins on the inside. So you can see these like slits cut in the pins. Those slits are making those, like the pin itself, kind of expand out a bit, and that is what's providing most of the friction. So if you just go in with pliers and like squeeze those together, it makes a huge difference on how easy it is to pull these apart and like separate them. So that was a super easy fix. And I am very grateful to Fox25 FPV for suggesting this in the comments to the last stream. It's a big relief that I can change it that easily, because that was pretty annoying. But yeah, that's the only real housekeeping from last week. And yeah, the main thing for this week is that some things have gone wrong. And I spoke about this last week, where I, very, very 20 minutes before last week's live stream, I turned on Jugglebot and heard this crackling sound, and then various things weren't working. And I have since discovered or been suggested what the actual problem was, and I'll get to that in just a sec, but it's, yeah, not ideal, obviously. So the problem was that the ground negative pin on one of the ODrives came out, or not the pin, sorry, the connection came out. And I actually noticed this in the stream. I remember when we were going around and I was having a look at things, that connection came out, and I remember saying something like, well, that's probably not good. But I had no conception that that could possibly be the cause of the problem in the first place. So the issue here is that when that ground negative connection came out of the ODrive, it raised this is my understanding, so this may, take this with a grain of salt. I am not an electrician by any means, but my understanding is that it raised the common mode voltage of that ODrive to 45 volts, but the CAN transceivers, which are the things that are doing the receiving and transmission of the CAN messages, are only rated to a variation across them of -2 to 7 volts with a transient of up to 25. So definitely not anywhere close to 45. And yeah, so the problem is that when this common mode voltage was brought up to 45 volts, the CAN transceiver was connected to that positive 45 volts and was also connected to like the system ground. And because there was such a big difference there, it just fried the transceiver. And big, big, big thank you to Oscar from ODrive for helping me with this. I was blown away by how quickly he realized what this problem was. I basically told him the symptoms, some of the symptoms, and I sent him my circuit diagram, and he's like, oh, it was probably a ground fell out issue. And I don't know if he watched the live stream, I don't think he did, where I noticed that the connection had come out. And I'm just blown away. Like he has such a good understanding of how these things work, and it's amazing. I was very, very impressed. But yeah, huge, huge thank you to Oscar for helping me out with this, and a couple other things which I will probably talk about later today. Oscar's been extremely helpful lately. Yeah, so what's the damage? It's one thing to know what the problem was, it's another thing to know what the actual symptoms of the problem are. And I haven't done a full assessment yet, partially because I have spent a large part of this week being frustrated at the whole system, because there was I thought I knew how bad the damage was, and I was operating under that assumption, which was that one ODrive was broken. And I was kind of okay with that. I was like, yeah, all right, that's fine. But at least I can use the other ones, and at least I can still do the throw testing stuff because I can just move the ODrives around so that the working one is on the hand. But yeah, I think it's a little bit worse than that. And I haven't done a full assessment, but there's at least the transceiver in the teensy, which I have here. So here we've got the teensy itself, if this will focus, and the CAN transceiver board on the side. And this little package was monitoring the CAN bus and like printing out how many messages were being sent, just so that I could like keep an eye on how much traffic there is on the CAN bus. And I will almost certainly be using teensies for other things later on. So this was just like a good practice for me to connect the teensy up to the CAN bus. And yeah, so this board is fried. At least the transceiver. I think the teensy's fine. I haven't actually checked it, but at least the transceiver's cooked. As well as one or maybe two ODrive transceivers. Same thing for the CAN bus. And I was talking with Oscar about this, and he was suggesting that I might be able to just replace just the CAN, like just the chip that handles the CAN, at least on the ODrives, and that will maybe bring the ODrives back to life. And I'm a little bit nervous about that because those chips are quite small. It's like main black chip in the middle there. It's pretty small, especially on this board. Like I think soldering that while avoiding that little tiny resistor down the bottom there is going to be pretty tricky, but I'll see how we go. I am putting in an order for a bunch more of these boards, and yeah, I'll just have a crack at taking the transceiver chip off of those boards and putting it onto the ODrive to hopefully fix the ODrive, because it's the same chip on both. Hopefully that works. We'll see. I'm a little bit worried that it won't, but you know, it is what it is. So, assuming that the damage is limited to those, and I'm very glad that the Jetson itself hasn't broken. I think the transceiver board on the Jetson may also be cooked, but that's okay because I can just replace it with another one. Although that soldering is quite tedious. But I'm very glad that the Jetson itself, which is the computer that I'm using to run Jogglebot, is not broken, because that was like $900. And I finally got it all set up, and I really don't want to have to go through that setup process again, because that was pretty painful, and I don't think I could remember exactly what I did to set it up. So thankfully, the computer is still alive. Yeah, so how can we stop this happening again? Well, the problem, as a reminder, was the power connection, the negative power connection just fell out of the ODrive. And if you're curious about like how this could happen, the problem is that I'm using these screw terminals on all the ODrives, and the cable that I'm using, let me grab it. I'm using this 10 AWG cable, which is thick, and it's a little bit too thick. So even with these ferrules on the end, I have to really kind of finagle it to get it actually, like that one actually fit really well. But usually I've got to really kind of coerce it to get it into the screw terminal. And I think the problem is that I had just finagled it in not quite the right way, and it had just not formed a solid connection, and it just literally just came out. I'm thinking that maybe the crackling noise that I heard was maybe the fact that it was loose and it was just kind of like sparking inside the screw terminal. I'm hoping that that was the case. I don't know. But in any event, we need to stop this happening again. So we want no loose connections whatsoever. And I was thinking, well, one thing that I want to do is change over to these bus bars so that for all places where my power line is splitting into multiple options, multiple different like outputs, I want to use one of these bus bars just so that the connections are easy for me to see and validate that they're all there, they're all solid, and it should be pretty easy to like chop and change things as well if I need to. Whereas before, like this cable is so difficult to change now that I've soldered this up in like exactly the way that I have. It's really hard to change it. And I've actually already like taken the cable that was coming off of here out, and I tried to desolder it, but I just could not desolder these joints because they're just too fat and messy. And yeah, so this is kind of annoying to deal with, and I'm hoping that the bus bars will be a little bit more modular and a little bit easier to work with, as well as being a solid, easily verifiable connection. My only gripe with them is that they're so big. And I don't know, is stacking them like that a bad idea? I kind of want to stack them so that it takes up a bit less space, because having them side by side, like that's so wide. I don't know. There's no connection between them, so I feel like it should be fine to stack them. But I'd probably like 3D print a little spacer thing or something, but I don't know. If this is a really bad idea, please let me know, because I don't want to break something else for a stupid reason like this. Yeah, another thing that I was planning on doing, sorry, I just realized my audio is very loud. Another thing I was planning on doing is to solder directly onto the ODrives instead of using those screw terminals. So what you can do is at the back of the board, you can see where the screw terminal comes in over, let me go big, over here, like the screw terminal, I guess we can look at the power one over on this side. The terminal itself is only connecting with these two little pins, but if you just take this connector off, you can solder directly onto these giant pads, and that will make a much, much, much more solid connection. But I'll get to that more in a sec. So that was my plan, but if I can't recover these ODrives, I may have to do something else. Yeah, another good thing, which is kind of foreshadowing what I'll show in just a sec, is that ODrive Pros are explicitly designed to not have this problem, because the CAN bus, like the section of the ODrive Pro that handles the CAN interaction, is semi-isolated, and it can handle a differential of up to 100 volts. So or around 100 volts. Even if the same problem happened where the DC negative pin comes out, as far as I'm aware, that wouldn't fry the CAN bus, at least. And hopefully wouldn't fry anything. Oscar was telling me that apparently this is a very, very common problem for the DC negative to come out. Maybe he was just telling me that to make me feel better, but I don't think so. But yeah, so they've gone to a lot of effort to make sure that that doesn't break anything on the ODrive Pros, which is great. Yeah, and that's why. So in other news, I have bought some ODrive Pros, and I'm very keen to give them a spin. They are pretty good. I've got this big old box. This is my mega ODrive box of like almost $5,000 of motor drivers and assorted things. So it's very expensive, definitely, but I'm super keen to give them a spin. And my big conundrum now is that I don't know whether I should change the system over to ODrive Pros or try and recover the ODrive 3.6s and use them. So I don't know, because I'm expecting it to be a little bit of work to recover all of the old ODrives, but I'm also expecting it to be a bit of work to use the new ODrives. And to be honest, I was kind of hoping to use the Pros, the new ones, on the next version of Jugglerbot, and I bought them now just so that I didn't have to like wait for delivery or anything when I do go to design the new one. So this means that I'll have to buy even more of these for the next version of Jugglebot if I use these on the current version of Jugglebot, because I want to keep the robot like still working when I'm designing the new one. So I don't know. I'm in two minds about swapping or not, and I feel like I know that if I do swap, then I'm probably not going to go to too much effort to recover the old ODrives, because I'm going to be focusing on just moving forward rather than fixing these things that I'm not using immediately anymore. I don't know. We'll see what I do. I think. Yeah, I don't know, we'll see. And another thing that arrived is, again, for the new version of Jugglebot, I have some new motors, which I was a little bit surprised how small they are. They are teeny little drone motors. And I got drone motors after the suggestion from, I think it was Alice and someone else, Zariah maybe, was suggesting that I should look into drone mode. Well, they were suggesting a website that mostly stocks drone motors, and I've been very surprised at how powerful drone motors are. I find it really hard to get a good idea of how much power I can actually expect out of them, because they're mostly spec'd in terms of like the thrust force that they provide using normal rotors, because they're designed for drones. And I'm obviously not getting any thrust out of them or anything like that. So it's a little bit weird, like converting across, but with ChatGPT's help, I feel pretty good that these motors should be strong enough to do what I want. They are 1500 kV motors. They spin very, very fast. And I'm thinking I'll gear them down for like letting me spin these really, really fast, but making the output a little bit slower. And that should give like super smooth, should be very powerful motion. And one related question actually that I have for anyone who's familiar with brushless DC motors is that these are rated for 6-cell batteries, which is around 22 volts. I have a 24 volt power supply, but I would like, if I can, I mean, why not, to use my proper power supply that I'm using for Jugglewatt, which is 45 volts. And so these are only rated for 22, but as far as I'm aware, voltage overpowering, like giving too much voltage to a brushless DC motor has a couple implications. One is that it will make the motor spin, if at like full speed, it will make the motor spin faster, and it's possible that it's like mechanically it will break because it's just spinning so fast. I'm not expecting that to be a problem because I'll be using the ODrive to monitor the speed and make it spin at the speed that I want it to. So it's not going to be spinning too fast. That's not a problem. And yeah, as far as I'm aware, when you increase the voltage, you allow more current to be going into the motor. So even at the same speed, with more voltage, it will be providing more power. That's my understanding. If that's wrong, please let me know. And of course, because there's more power being provided, it's going to heat up more. So I'll have to be more mindful of the temperature of the motors. But these are so cheap. They're like 20 bucks or something. Like, it's nuts compared to the other motors, which were like, including shipping, closer to 200, I think. I'm pretty sure. Yeah, big difference. But I'm keen to give these a go. And I will talk about these more a little bit later. They come back again. What do you mean by you limit the amps, Juma? And yeah, so the ODrive will be used to monitor the speed, to keep it going how fast I want. Yeah, that's it on that. So yeah, what about catching? So last week we left off with some plans to make a compliant hand. And let's see how that went. So as I said before, I was a little bit frustrated this week with the breaking of everything, and part of me just didn't want to deal with it. So I have kind of left behind all of the problematic stuff and have just kind of charged ahead with the hand testing just because I wanted to see how it would work. That's something that I do like about this project quite a lot, is that there's so many different aspects of it. So if I get too frustrated with one part, I can just be like, no, that's a problem for later me. Right now, I'm going to do what is fun. And this week, the fun thing was the catching testing. So it's kind of like procrastinating, but it's like productive procrastinating. It's great. Yeah, so let's see how the catching is going. So I have attached everything up here. Maybe let's put this camera here. Currently, all of the communications is just over USB because the CAN stuff isn't working properly. So USB is fine, but it's a little bit unreliable. But thankfully, in this system, it's a fairly straightforward system, so I haven't actually had any issues so far. And I'm actually just thinking I might move this camera. Let's put it over here. Oh, that's a bit close. Hang on, let me move the robot over. Cool, that should work for now. And maybe I can put me on here as well. There we go. Cool. Yeah, so if we turn it on, right now, I guess I'll give you a full tour actually, because I've got the fuse in there as well for the first time. I'll just turn it off so we don't get the fan noise. So in here, we have the hand motor down the bottom, and that is connected to the output spool. This string goes around the spool, goes up through the fuse up here, and then, is that focusing properly? I can't really tell. Then the strings go up the same way that they did before. Something actually that's interesting while I'm holding the camera here that I just want to remark on is that one of these strings broke in my testing, this one here, and after replacing, it broke for, maybe I'll explain a little bit later why it broke, but it doesn't really matter for now. But after replacing this string, I realized just how much these strings have stretched or like thinned out. Like this one here is super thin, And this is the same string, and even actually in this video, you can still see the difference. Like, there's a massive difference in the thickness between the two. So I'm kind of surprised by that. And yeah, I don't really know what to make of that really, but yeah, I don't know, not ideal. But thankfully, actually, in better news, the length adjustment thing that I have in the hand actually worked really, really well. I had to kind of smooth out a lot of the overhanging part of this printed part, but it works really, really well. So I basically just lift it up like this and then see which arm hits the top first, and then I can adjust the position of the little slider inside here, and that adjusts the length of that string with like very, very fine precision. And that seems to work quite well. I'm pretty happy with how that has turned out. Yes, let's turn it back on. So right now, what I was hoping to do, the goal here was to have the ball come in and have the motor be like soft enough that when the ball comes in, it just pushes the motor and forces it to turn with some amount of resistance, but like a tuned amount. And then as the ball continues to move down, the motor will like act harder and harder and harder to slow the ball down. But the key part here is that the ball has to be able to move the motor in the first place. It has to be able to like kick it to get it going. And we'll see how that goes. So another fun thing about this actually though is that I tried doing some catching testing where I was just dropping the ball in from above, but it was a little bit tricky to get that to time properly, to be like, so that it was like ready, waiting for me to drop it. So I have started doing some throwing testing as well, which is definitely more fun than the catching testing. Although the catching testing I think will be much more satisfying when it works. And yes, Juma, it's very much like a damper is the idea. So right now, I have it set up, so I'll run it now so we can see it will raise up. This is similar to the homing sequence, and it can throw. And if I didn't catch it then, it does land back in the hand with some reliability. But there is an interesting problem with this. Actually, yeah, so before I get into the problem, the sequence here is that it goes up until it hits the top, and while it is moving up, it is monitoring the current in the motor, and then as soon as the current spikes or like hits a certain threshold, which I have just set manually, then it knows that it's at the top, and I have told it how long the stroke of this part is, so we can go the whole way back down, and then it throws at a particular speed. Also, if you want to see the code for this, you can. It's on GitHub. I'll put a link in the description for this video. I was going to before, but I forgot. I'll put a link in the description to this video, so after the fact, after the stream is done, you'll be able to find the link there. But yes, there is an interesting problem that has been happening and did just happen then, so this is a good example. When the hand goes up, some of these strings pop off the pulleys here, so it's kind of hard to see, but this string is on the pulley, this string has come off the pulley, and it can be a little bit fiddly to reset, especially with the camera in your hand. But yeah, that's obviously not ideal. And thankfully, I've got a friend staying over with this right now, and his phone can record in fairly slow motion. So we were able to record this video yesterday, and it's very interesting watching this string come off. So you can see it comes down, and I'm just going frame by frame. Let's go a bit faster. We can see as it goes up, the string just comes off the pulley, and then it quickly zips back down again. And for some reason, VLC doesn't have a shortcut for previous frame. It's got a shortcut for next frame, but not a previous frame. Like, what? But anyway, I'll just go back through again. So I'm pretty sure what's happening here is the hand speeds up, and then once it's reached its peak speed, it starts to slow down again. But I think the string is stiff enough that the hand has enough momentum that while the motor is slowing down, the hand continues going with its momentum, and because the string is so stiff, it stays kind of straight, like it doesn't just wrap around the pulley, and that's what causes it to to flip over. Very unexpected problem. I did not anticipate that being a thing at all. So yeah, I haven't really thought long enough about what the implications of this are and how we can fix this, but it's a very interesting problem. A similar one is that the springs down here, the constant force springs that act to pull the hand back down again, sometimes they get too much momentum, and when the hand goes up really, really fast, they keep unspooling and they come off of the spools down the bottom. And that's very annoying to set up. It's really frustrating to get those springs back on the pulleys. But in better news, in more exciting news, this setup here is very, very powerful. It can throw, I don't remember exactly what settings I had. I've changed a bunch of settings around over yesterday, but at one point, the ball very, very solidly hit the roof. And I think that's pretty good. So I'll try now. This is with like 1.5 times the amount of acceleration that we just had before. And let's see how this goes. So we'll raise up, home, go back down, and then so that hit the roof. Oh, I should stop catching it. It's just, it's instinct for me to just catch the ball because I don't like it landing and like hitting stuff beneath. And nothing broke, so we can just reset again. Sometimes I do get errors where the motor will like overspeed at some points, but usually it's fine. And we can see, actually, oh, I don't have it set up for that. Let's see if we can go even faster. One thing, actually, another thing that I will mention is that these, in retrospect, these mechanical fuses are amazing. They're so good. I'm so glad that I have them because there have been a few times where the hand has, especially when I was tuning that homing sequence where I had too much current limit, I could see like the whole of Jugglebot getting like pulled down into the ground. Like more than, if I push it down quite hard, I can't get it to compress the same way that the motor was getting it to compress. So I'm very glad that the mechanical fuse is in there to stop anything breaking, basically. But they do tend to have very violent explosions. I definitely have shrapnel around my room in here that I have not been able to find. And I know that because I have like pieced together all the little bits that I do have, and there's like a handful missing. So I'm not too keen on that. But other than that, they do work quite well. So let's try this with like significantly more speed than we just did. Let's see if we can see what it does. Ah, I think I got some errors before. But that's okay because they are easy to clear. Just give me one sec. All right, now let's see. Actually, something was weird there. And I'm actually thinking I might just put the camera somewhere else so you can see how high the ball is throwing. Maybe up here. Oh, it's too high. Oh shit. That was not good. Oh, it's still alive. Whew. That was not ideal. I just dropped that. Dropped it from up on here down onto the ground. Let's try this. You still can't see the roof. But hopefully you can get a bit more of an idea of how high it's throwing. But something here, yeah, when these strings come off the pulleys, they get really jammed up. And that's what caused the other string to break before, is that it got stuck between the pulley and the plastic, and then it just like rubbed and broke. So I'm thinking I have encountered this problem a lot, as you can potentially imagine from all of the linear actuator work that I've been doing. And my solution for this problem, I can actually show you on here. My solution for this problem on the linear actuators has been to, above the pulleys where this problem happens, maybe I'll get one that's in a bit better light. Above the pulley, I have this cutout, and this is, I ended up like changing it a little bit to this, but you can basically encourage the string to go like directly above the pulley rather than going out around the side. So with this like tapered ceiling sort of feature, when the string does go loose, if it does in the actuators, which it shouldn't, but if it does, it's encouraged to kind of like go up into this middle spot, and then when it gets pulled tight again, it lands straight back on the pulley, rather than going out over the side. So I think I might do something similar to that up in here. But that requires reprinting parts and designing things, so we'll see. Let's put it there. All right, so we should be good to go. I think it's fine. Yep. Oop. Wow, okay, that was that was with like half of the full stroke length. So definitely ought to go further. That's weird. Let's try one more time. And then I've got some other stuff to talk about. Why are you getting errors? What's that about? What errors are they? Current limit violation. I don't understand that. So I set the current limit to be like 50 amps. And I'm still getting current limit violations. Even though it's definitely not drawing 50 amps. Yeah, not as high, which is weird because it was set to be faster. Anyway, it can throw very high is the TLDR of this setup with the current motor. And it can definitely throw higher than I need it to right now. I am pretty happy with a 1 meter throw height is the height that I usually throw at around for like 5 balls. And yeah, especially with like 2 balls in one hand, I think 2 balls in one hand will be is a very approachable goal for this version of Jugglebot. And 2 balls in one hand, you definitely do not need a full meter. So the fact that if this can throw into the roof, which is probably closer to 2 meters, is primo. However, you may have noticed, I guess because I didn't let it catch, you may not have, but if I change over to this view, so this is, if I fix this string up, interestingly as well, that problem with like the string hopping over the pulley is consistently happening with one pulley more than the others. And I'm not too sure why. My suspicion is that maybe the string has a bit of twist in it, and so that way when it gets loose, that twist causes it to kind of move over to the side, whereas the other strings, for whatever reason, don't have that twist, and so when they get loose, they just kind of stay straight, and then just happen to land straight back on the pulley. Maybe, I don't know. But yeah, so this is currently set up with, the motor is off, so it's in its most like, I don't know, restful state. But even in that state, if I drop the ball on, it still bounces off. The motor has too much inertia and doesn't allow the ball to just cleanly come through and force the motor to move. So, bit of a problem. There are a couple solutions for this, I think. There's a lot of different ways to approach this. But the end result is that there's too much inertia in this current system as it is right now, and that needs to change. So, I'm thinking, I've got a few thoughts on this that I have been developing, but one of them is that I want to change over to the smaller motors which have like basically zero inertia. They're so small, so much easier to turn. They've got much less cogging torque, I think it's called, where it like wants to sit in the little detents. Super easy to spin these. My concern is that these motors are designed to spin super fast, and that to get the power output that I need to throw the ball high enough, I will need to gear these in some way, and I'm worried that by gearing them down so that the output speed is slower, I'm worried that by doing that it's going to increase the inertia of this system high enough that the same problem happens here, where the inertia is too high and the ball can't get through, basically. So my thinking is I want to just make like a test rig. Well, my first plan is, let me step back a sec. There have been a few people who have been suggesting that the inertia is a big problem here. Oscar is one of them, and John Benno is another. And I believe them that inertia is a big problem, but I cannot wrap my head around how the inertias relate, how the inertia of the ball relates to the inertia of the of the hand, and how I want those two to be kind of like scaled to each other. So I'm thinking I'll just make a test rig where I will remove the constant force springs and then remove the motor from the equation. And instead of the motor pulling the hand up, I'll just attach some masses and then start off with like 0 grams, go to whatever the law, I think I've got 50 gram masses, but go up in whatever smallest increment I have and just drop the ball on and just see what happens. Because I've been thinking a lot about what it takes for an object to bounce off of another object, and it is super not obvious to me. It is very hard for me to conceptualize what is going on there. And of course, like, I did mechanical engineering in university and we studied all sorts of like coefficient of restitution sort of stuff, but it's all very like hand wavy. It's like, oh yeah, we just do experimental measurements and see what we get. And that's what the coefficient of restitution is. And that's what describes what this, like, whether these things will bounce. And yeah, it's very hard for me to visualize and work with in theory. So I'm hoping that by setting up this experimental rig and just playing around with it, I should gain some intuition as to how this is behaving. My thought is that my like very off the cuff intuition is that if I get the mass that is pulling the hand up to match the mass of the ball, then it should not bounce off. And then once the mass that's holding the hand up is greater, like once the inertia of the hand is greater than the inertia of the ball, then it will start to bounce. But how much more can it be? And how, we'll see. I think that will be a very interesting experiment to run, and I'm very curious about the results of that. So yeah, that's one thought. Just looking at comments. Flow Hunter, am I considering tracking the ball? Yes, absolutely, but that is a problem for later. I have many ideas for that process, but my thinking is that it would be a bit wasteful to spend too much time on those ideas right now because I don't even know which ones I will need. So just to give you a very quick recap, my first thought is that I'll use a 3D camera, which I've got a couple different 3D cameras, but I'll use like the best one that I have and use that to just track the balls and look where the robot is and then compare those two, and that should be fairly accurate. But of course, 3D cameras tracking a ball is not going to be super accurate, so there's going to be a bit of noise there and that will get a little bit messy. But another plan that I'm more keen for is having what I've been calling the laser gate on the output of the hand. And so the idea is that there's a laser and a photodiode, and we know the diameter of the ball. It's very, very spherical. I've measured it in a bunch of places and it's surprisingly spherical. Yeah, ball comes through, we know the diameter. We can measure when the laser is broken very precisely with a photodiode, and based on how long the laser is broken for, we can figure out how fast the ball is moving. So even though we have a rough idea of how fast it will be moving just through like open loop control, using this laser gate, I should be able to get a very good idea of how fast the ball is moving. But I don't know how necessary either of these ideas are, because for all I know, this robot could be precise enough that open loop control is fine, and I can just tell it, throw from here, and the ball will be here. You just have to trust yourself, Mr. Robot, and then it will go there and the ball will be there. And yeah, that might work. So my plan is to get things working in open loop control to their limits, and then after that consider, okay, these are the limits and these are the options that I have for improving this with regards to tracking. Yeah. So John Benner, the reflected inertia of the smaller motor may be higher. Yeah. I think Oscar mentioned at one point that when you gear motors down, the effective inertia of the motor goes up by the gearing squared, but I don't understand how that works, so I'm not sure. But it will definitely go up. So yeah, my very rough idea here is that the long-term gearbox that I will have on these motors would be a cycloidal drive because they're amazing, and the more that I think about it, the more keen I am on making one just because they're cool. But that's obviously a bit of design work, and so I'm thinking is that I'll make a test rig where I'll have an output gear on here and then like secondary gears that are of different gear ratios, and those will be connected directly to the hand, and then I'll just test different gear ratios, whether I can drop the ball in and and if this doesn't have enough inertia and so on, and if this can throw high enough. I've slowly been becoming more experimental over time. I have learned the hard way that often the theoretical specs of things are not what you will actually be able to achieve, and that's really kind of changed my view on theoretical analysis of these sort of systems. So I'm slowly becoming more of an experimentalist, and I want to make a little test rig to see how good these motors actually are. And like, they're so friggin' tiny. This is like the smallest motor I've ever seen, I think. I'm really keen to give them a spin. Actually, one thing, while I'm holding this, before I forget, how do you attach things onto these motors? Like, it's just it's a circular shaft. Like, I'm thinking I'll print something that can like go into these like grooves in here. But like, if you put something on this circular shaft and clamp it down, even if you clamp it down really hard, like surely it can still slip on the output shaft. I would have thought there'd be like a keying on the shaft so that you can put like a similarly keyed thing onto it and then it won't slip, like a little hex pattern or something. But no, they're circular. So I don't know what's supposed to do that. We're supposed to do that. Juma, I don't think the mass will change the bounce. I don't know, because if the mass of the hand was like 1 million tons, then the ball coming in is not going to do anything. But if the mass of the hand is 0, then the ball is just going to come through and start moving the hand at the exact same speed, which is kind of what I want. So I think I want the hand motor to have as little inertia as possible, like very, 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 very low, so the ball can just come through with 0 impedance until the motor starts kicking in and slowing it down. So yeah, I definitely want very low inertia, but I don't know how low. I don't know what that threshold is, at which point it will start to bounce off. Thank you, John, for helping trade off configurations. I do like your spreadsheet. I should actually upload my spreadsheet. So John uploaded a spreadsheet onto Zulip for some calculations for the hand, and I have done very similar calculations actually. I'll upload them to Zulip today after the stream, if I remember. I'll try to remember. Yeah, analysis is good. Analysis is definitely good. It is, I agree. But I think experimentation is, I don't know. We'll see. I'm flip-flopping between the both. Yeah, Yoroko is saying brushless DC motors are fine, so they're not too affected by the voltage, but the heat will be a problem. Yeah, yep. I have a bunch of fans that I can put on these, and actually, to be honest, these motors, like this is a drone motor, so as far as I can tell, the drone motor is designed to run flat out, full duty cycle while the drone is operating, and then it's just be off for like a long time afterwards. But for the hand, especially if I'm using this for the hand, its duty cycle is going to be like nothing, because it's powering really hard once to get the ball out, and then it's just chilling for like a second or so, and then it's working as a generator, which I don't know if, surely no, the input voltage wouldn't matter if it's working as a generator. I don't know. I actually don't know how that would work. But in any event, it's only doing a little bit of work when it's catching. So its duty cycle is going to be low, so I don't think heat should be too big of a problem. And anyway, these are so cheap that I'm happy to just break some. I'm keen to push them to their limits and see how fast I can get them to go and how much power I can get out of them. That is a good point though, Yoroko, with the motors are designed to be cooled by the rotor. That is a very good point. So maybe their heat tolerance is actually less than what I would need. We'll see. We'll see. With equal masses, all of the kinetic energy of the ball will go into the hand, which will turn and to dissipate in some way. But that depends on the coefficient of restitution, does it not? Like how... maybe you're right. I don't know. I've got to do some tests. I feel like, especially for intuition's sake, I find it's hard to develop an intuition for something based just off of theory. It takes a lot of experience with theory to have that sort of intuition. But I have a sense that if I get some experimental experience, then that should, I don't know, maybe it's just my human brain is geared more towards like actually physical things that I can see and interact with. But yeah, I'm interested to see how this goes. If I know the location and the speed of the ball to some degree, why not move the hand back and slow the ball to stop? Maybe better to proactive to move the hand to receive the ball. Yeah. So I think, if I understand you correctly, you're suggesting that if I know that the ball is coming in or about to come in, I can preemptively start to move to receive the ball on its way. As we talked about last week, I don't think it's physically possible to have the hand match the speed of the ball, but you are right that it could get pretty close. So I could get the hand moving so that it doesn't need to force the motor as much as it would otherwise need to if the hand was completely stationary. That is absolutely correct. And I have tried that. I actually have in my testing script that I was just using then to throw the ball up, I have a little like catch routine where it does exactly this. So when it throws, I calculate how high the throw will be or how long it will take for the ball to come back down to the hand based on how fast the hand was moving, which I measure off of the actual like encoders. So it's not just a theoretical value. It should be fairly precise. So yeah, we know when we threw and we know when the ball is going to be back down again. And so I have it set up so that it will start to move down and then have a very low output torque limit so that it does exactly it should do exactly what you're describing, where it starts to move down, it can't push very hard, so it starts to move down and then the ball comes in and it can't resist, it can't like immediately bounce the ball back because the motor is not allowed to push that hard. But the problem is that the motor has so much inertia that even with that super low torque limit, it's still too much and the ball just bounces. Like sometimes it doesn't bounce out. Most of the time, to be honest, it actually stays in the hand, even though it's a very aggressive collision. And I'm pretty happy with how like the layout of this top part works. It does a really good job of like funneling the ball in. But yeah, I think even with that preemptive movement, this current setup still has too much inertia. But you're absolutely right that will be a very useful technique for any system, irrespective of how much inertia it has. I do agree. However, I will have to note that when I'm juggling myself, I am fairly sure that I'm not moving my hand in anticipation of the ball. It's like I'm waiting and the ball comes in and that forces me to move my hand. So, I don't know, take that with a grain of salt, I guess. Yeah, so a couple other thoughts. There's a lot of things that I've been thinking about lately. Another one is that because of these springs coming off of their spools, I'm kind of wanting to get rid of them. They're just too much hassle. And in place of them, the causality of what I'm saying here is not quite like the order in which I arrived at it, but the end result is the same. So yeah, in place of these springs, we can have a bidirectional drive for the hand so that the motion of the hand is directly keyed to the position of the motor. And in exactly the same way that I've done the linear actuators. So that whenever you move the output of the linear actuator, the motor will have to move irrespective of where you're moving the output. Whereas like right now, if I pull, the camera's in the wrong spot. Let's go here. The OBSbot, if you're listening, this would be so good if I had a bunch of cameras all around the room and I didn't have to move them around. How good would that be? If I move this hand up, the motor is just sitting there not doing anything, right? Like it has no understanding that this is being moved. And that actually just came off. Oh, wow. That's interesting. So in those tests, literally just this morning, we've bent the hook of I don't know if you can really see that, the hook of the fuse is all munted, which is not ideal. Yeah, so what I want to do is key the motion of the motor to the motion of the hand. But that's a bit tricky to do with the motor being mounted on the base. There's going to be a lot of strings going around in lots of different directions. I do have a good idea of one way that it could work, but it's a little bit tricky. And to fully describe why this is tricky, you might be thinking, okay, it's fine. Like you can just have a string that goes from the bottom of the hand down through this bottom section and down to the base. But when the hand is off, when the platform is off on an angle like this, we need to make sure that the strings are all kind of like, they all need to be routed the correct way. And that's not super trivial, I think, at least. Yeah, so the other option, as was suggested by John Benno on Zulip, is to mount, and actually I think a couple other people have suggested this in the last couple of weeks, is to mount the hand motor onto the platform so that it would be presumably somewhere on here. And I actually quite like this idea for using these new smaller motors because they're so light. Like this whole thing is, I think it's less than 100 grams, but the old motors were like almost a kilo each. So I don't really want to put the old motor on here anywhere. I mean, it would have to be here, otherwise the symmetry would be ruined and we can't have that. But this could be on here, like that weighs nothing and that's fine to be moving around, even with a little gearbox attached to it. So I think that could work with these new motors. But what I want to do is do some testing with these new motors mounted to the base, just because we're doing like 1D linear testing. And then once I have a better idea of what works, if something does work really well, then with like a particular gearing ratio and everything like that, then I'll be mounting the hand motor onto here, which does raise some interesting questions for how to get the cabling to there. Like, should I have just the 3 motor cables come down from the motor to their base, or should I move the entire ODrive up here? Probably not, because that's going to have more cables, but I don't know. Because there'll also be encoder cables too. So it's, yeah, I don't know what would be the best option for getting anything to the hand, because that needs to be able to move around. But that's a problem for later. One other thing as well is that if we do set up the bidirectional string to actuate the hand, that will mean we'll need another fuse, because where the mechanical fuse is right now, that only breaks or like has any impact at all when the hand goes too high. It doesn't do anything when the hand goes too low. So if I have the downward motion being also actuated by the motor, then I'll need another fuse to stop the hand from ramming into the base too hard. So that'll be another interesting thing. Or I can design a different sort of fuse that works for both somehow. I think someone's idea of like the spool inside the spool with a shear pin might work quite well for that, because then I can key that to both of them. But we'll see. That's another problem for later. There's one other main thing that I want to mention that I think it was Jean-Marc was suggesting on Zulip, is this stuff that is pretty incredible. It's called D30 or D30. Let me go on here. So you're suggesting I could use this stuff to like line the hand, and this would do a very good job of absorbing the bounce of the ball. So this is a ball bearing just on normal foam, obviously bounces a fair bit as you would expect, but when we drop it on this stuff, boom, look at that, nothing. Pretty impressive. So I'm considering buying some of that and seeing if that would help, just like lining that up, lining that in the hand. Maybe it will, but it's a little bit expensive and it's hard to find in Australia. So we'll see how we go with that. Yeah, the final thing is that there will be no stream next week, because I don't know if other people, I guess surely other countries celebrate the Easter weekend. It is in any event the Easter long weekend for us in Australia, and I will be spending a lot of the next week just kind of chilling out and trying to not think too much about all my broken ODrives. Yeah, as I've been trying to do this week. Just kind of put them out of my mind. Don't think about them. It's better that way. Yeah. Yeah, so hopefully I will have figured out what I'm going to do with the whole control setup with regards to all the ODrives by 2 weeks from now. We'll see. But in any event, yeah, there'll be no stream next week. So, yeah, I'll see you in 2 weeks. Yeah, I think that's everything. Bit of a scatterbrained week this week. I've been flip-flopping a lot between being frustrated by things and being excited about the catch testing, and then being disheartened again when the thing had too much inertia, and a bit of a roller coaster. But I know that it will work soon. Soon being uncertain. Yep, we'll get there. We'll get there. All right, cool. Thank you for joining me. And that is actually a very good point, Ash. So Ash has suggested, surely the surface you have the D3O sitting on would matter. Although, interestingly, I actually haven't found these, I haven't really searched for these videos, but Gene Mark, the one who was suggesting the material in the first place, said that there are videos of the guys in the lab coats there's like a gel version of this D3O. They put it on their hand and they're like whacking it with hammers. So I don't know. I think it is just like an intermolecular thing, so it doesn't really matter where it is. But I would be interested to know what would happen if you got like a ball of that and a ball of something else and like made them collide in the air. That would be interesting. It's like a coefficient of restitution 0 material, which is very odd. Maybe I should just get some to play with. I'll have a look. Yeah. But yeah, thank you for joining me, and I will see you in 2 weeks. Until then, I hope you have a good one.